Good morning, everybody. This is Carl Griffith from Graybar, and I want to welcome you to our G2 Talk webinar today. Our discussion today will be around lighting in educational campuses. And if you look at the slide there, you can tell we're going to talk about controls and how you can become a control freak. Now, before we get started, I'd like to just give you a little bit of information about Graybar. Graybar helps our customers power, network, and secure their facilities with speed, intelligence, and efficiency. And today, the facility that we're talking about are educational facilities. Within Graybar, we have a program that we call PowerSmart, where we have experts around the country who are focused on the renovation and retrofit of existing buildings and helping customers reduce their energy costs and improve lighting in those facilities. If you would like to consult or have a conversation with one of the Graybar people about lighting in your facility, all you need to do is in the Q&A box that you see, or the Q&A tab that you see on the screen, just click on that and type the word assessment in there, and then we'll arrange for a Graybar person to come by and chat with you and possibly do an assessment and take a look at the lighting in your particular facility. If you're one of the first 50 people to log on to the webinar today, we're going to provide you with a cup of coffee, so check your email. You'll get a certificate in the email that you can exchange for a cup of coffee at one of the major coffee chains in North America. Again, there is a Q&A button at the bottom of the screen, and we will have Q&A during this webinar. If you'll type your questions in the Q&A box, we'll get to those questions near the end of the webinar, and we'll go through them. If we don't make it through all of them, we will respond to those we don't respond to live via email. But everybody's question will be responded to during the webinar. This webinar and other G2 Talk webinars are all archived at graybar.com. So if you go to graybar.com and click on the G2 Talk webinar logo and follow the link to the archive, you could look at this presentation again, or you can look at any other G2 Talk webinar that we've done in the past. Today our presenter is Tim Hogan. Tim Hogan's an expert, subject matter expert when it comes to lighting in the education space. He's been with Acuity Lighting for 19 years, and he's the vice president of the education market. You may have run across Tim if you've been at other webinars or seminars or trade shows around the country. He keeps his schedule quite full with speaking and teaching engagements, helping people understand lighting. He's very passionate about lighting, and he talks about it this way. He says that he likes to inspire, educate, and enable. And that's exactly what Tim's going to do today. He's going to inspire us, educate us, and enable us when it comes to lighting in our educational facilities. He's very excited about lighting. And without holding up the webinar any longer, I want to introduce to you Tim Hogan from Acuity Brands.
Carl, thank you very much, and thank you everyone for joining the webinar today. In a short amount of time, we're going to try to focus on a very specific topic that we think will help people start to address the lighting challenge on their campuses. As Carl said, I love to talk about lighting. I love lighting. I love what it can do for the campus, how it can improve the visual appeal, how it can make learning more productive, and how with the latest technology and latest thinking, we can save a lot of energy at the same time. So it is about creating a better space, a better learning environment that costs less to power and to maintain. For those who don't know Acuity Brands, just a quick introduction. Acuity Brands is one of the largest lighting companies in the world, and you may have never heard of us. We're a collection of about 21 different brands of lighting and controls companies who've been doing this for 100 years or more in some cases, like Lithonia Lighting and Hall of Fame and Gotham and Peerless, with great controls brands like Sensor Switch and LC&D. It's just a really smart group of people who are now pulling together lighting solutions to help on the campus. About 6,500 people, about $2 billion in sales, and we're online at acuitybrands.com. But what you came to learn about today is about your space and how campuses can stop wasting lighting energy, how simple projects can have big returns, and how to start identifying the key spaces and how to start solving that problem in those key spaces. So that's the thing we just really want to kind of focus on. Educator's Challenge. One of the things we want to do through this is to collect a little information from you. So to make sure that you're staying engaged and to help us tailor the conversation, just give me a sense. There's a poll. It should pop up on your screen, and it should be interactive. And here's the question. As you think about your campus, what percentage of the lighting is controlled at the switch? That is, a person turns it on or off in a manual way every day. So let's just take a minute. There's not a right or wrong answer. Just take a stab at it. Pick your answer and go ahead and hit submit when you're ready. One of the things we know about lighting is that it is left on. And one of the greatest ways to save energy is, as we all know from yelling at our kids, is to turn the lights off when you leave the room. So we'll give everybody just a few seconds to make your decision and make a choice and click submit. In a few minutes, this is the first time we tried this polling question, but we think in a few minutes we'll be able to see your results. Okay, we're going to move to the next slide. The challenge as a facility director is to improve the campus environment and at the same time spend less money. Every facility director I've ever talked to has that same challenge. And what I know from talking to these facility directors is they care about the mission of the institution. They didn't become leaders in the facility field without understanding and caring about the mission. They're not just buildings, they're schools. And schools have a noble purpose, and facilities enables that and supports that. And facilities has to find a way to do that while spending less money on energy, less money on maintenance, and doing things faster. I think when there's a hall of fame for people who can squeeze the most out of a nickel, or in this case a penny, I think a facility chief will be the first person inducted into that hall of fame. One of the things we know is that schools, K-12 and higher ed, spend about $14 billion on energy through the course of a year. That's more than we spend on the school nutrition program. And we also know that at least a third of that energy is wasted. So we're approaching something like $5 billion that is sent to the utility companies. I love utility companies, but I'd rather keep the money for education. That's $5 billion that gets sent to the utilities that could be used for educational purposes. And so what we want to do as facility leaders is try to figure out how we can improve that number while also improving the learning environment. Some other information that we look at is we try to understand where the opportunity is. And I'm a huge fan of using data and analytics and research to understand that the efforts we take are going to produce the most results. So in looking at educational stats, this is data from Department of Energy. And a couple things that really stood out to me as we put this information together. And first is the vast majority of the lighting in your spaces is linear fluorescent. Probably not a surprise to anybody. According to DOE, and I think this is from 2011, is 85% linear fluorescent. Not a big surprise. At that time, there was no LED. And since outdoor is not a huge part, there's not a lot of HID. The other thing that was striking in this set of information is that 83% of the lighting is uncontrolled. There is no control on the lighting other than controlling it at the switch. And I can't tell you how many educators and facility leaders I've talked to who said, oh, we have a training program, we have signs, we teach people to turn the lights off. And I always say, well, how's that working out for you? And they go, not too well. It's really difficult to get people to change their behavior. So I see those two numbers and I see a huge opportunity. If we could figure out how to turn the lights off when people aren't in the space, we could save a lot of energy. And what we know is that more than a third, about 40% of the energy that is spent in a school is spent on lighting. If you combine heating, cooling, air handling, then those three add up together to be about what lighting is. So huge opportunity just by turning the lights off. So what we see here, so looking at the survey results, is that we think a third of you believe that most of your lighting is controlled at the switch. So we're going to call it half of you think at least half of the lighting is controlled at the switch. Just kind of summarize that up. So that says to me that some of you probably have newer schools where energy codes required occupancy sensing and vacancy sensing. And some of you probably have older buildings that just haven't been able to renovate those yet, or you tried sensors and just didn't like them. So that's interesting information, and thank you for sharing that. One of the things that I always encourage people to do is to understand where they're spending their energy. Right? Where do we want to spend our energy? And so we use a tool called a data logger. And I don't know how many of you have tried this in any of your buildings, but it is a great way for facility leaders to, as I say, do their homework. The way this works is our sensor switch brand has cases of these data loggers. You see a little picture of the data logger there. It is about the size of a hockey puck. And it is an occupancy sensor and a photocell in one. And you get a case of those. I think there are 42 in a case, 48 in a case, about 40 in a case. And you put them out through representative areas of the campus. So you would put these 40 out in a way that when you collected the data, it would be extrapolatable, if that's a word, extrapolatable to the whole campus. And what happens is it pulls back a lot of, so after 3 weeks, you go collect all of the sensors, you plug them in with the Cat5 cable to your computer, USB cable, and it sucks the data out, and it then runs reports, and you can now see exactly when the lights were on and exactly when the space was occupied, space by space. The great news is all the data gets pulled into a simple little bar chart like this that you can give to the boss, right? Because the boss needs a picture, right? At least my boss needs a picture. Fewer words, the better. And what you can see is that in this space, this is a high school space, and if we were able to turn the lights off when the spaces were unoccupied completely, we would save 42% of the lighting energy just by turning the lights off. One of the things that you will notice, for example, the blue bar is that the lights were on, and the red bar is the space was occupied. And somebody turned the lights on in the storage closet and just didn't turn it off the whole time. Hallways are almost always a huge opportunity for savings. We don't expect people to be in hallways throughout the course of the hour. We have a migration every hour that sends people to the new space. Another good example there is the locker room. So this was a high school building. We've done a lot of these reports for every kind of school building you can imagine. Here's one that was done in a middle school. So restrooms, I don't think that the high school project we looked at tested their restrooms. They either had sensors or they didn't want to try sensors there. But in this middle school, we see that restroom lights are on all the time, and the space is unoccupied about a third of the time. The gymnasium has the same problem, and the gymnasium has the added problem of, if it's an older building, an older lighting system, it's probably HID, which can't be turned off and on easily. So there's some explanation beyond lack of sensors. One of the things I would like to offer as a follow-up to the event, I think we have some links at the end, we have done aggregated versions of this data logger data to basically 6 aggregated reports. There's a report for small, medium, and large K-12 schools, and then a small, medium, and large university buildings. So I think there's Actually, it's small, medium, and large elementary, small, medium, and large high school, small, medium, and large university. So there will be a link in the back where you can find those reports. So what I tell people is you don't have to do the homework. You can kind of copy and cheat somebody else's. It's going to be about right. But if you want to be able to do, in particularly, a before and after, this is a great project to do. You do the data logger project. You do sensor project in certain key areas, you redo the data logger project, and now you know with assurance and with data that the project that you've piloted will pay off when you scale it across the campus. So I think it's a great way to kind of move forward in a scientific way. So that's the data logger. And one of the things we talk about a lot is this notion of a high-performance lighting system. So if we kind of pull up from just sensors for a minute, what we talk about is having the right kind of light, the right amount of light, where you need it, when you need it, at the lowest total life cycle cost. That's really the goal in a kind of a long statement. Because we need different kinds of lighting for studying in a classroom than we do for audiovisual presentations. We need different kinds of lighting in a gymnasium for competition mode than we need for night mode when the facility staff or the maintenance staff is cleaning up. So we want to put the right light right where you need it, when you need it. If that didn't matter, we would just turn the lights off and give people flashlights, I suppose. This notion of a high-performance lighting system requires a combination of strategies. And if we could go all day, we could do an amazing workshop where we talk about the 4 components of a high-performance lighting system. So the evolution, the revolution, I suppose, of LED sources, smart controls, daylight harvesting and daylight integration, and then useful and usable software to manage the visual environment. We've had dramatic technology changes in all 4 of those areas. I guess daylighting hasn't changed in and of itself much in the last, I don't know, millions of years. But the way we can harvest it and the way we can use it is far better today with advances in solid-state sources and smart controls. So for purposes of the webinar, we just really want to home in on one facet of this high-performance lighting system. We're going to focus in on controls, okay? Now, the great thing about controls is they're very flexible, and there is a wide collection, a wide set of tactics that need to be employed to maximize the control system, right? A very simplistic, inappropriate control solution for a space will result in a bad experience for people who have to work and teach and learn in those spaces. There's a lot of flexibility in controls, and that makes it a little confusing. One of the things I talk to people about is you have to have this layered strategy of controls, everything from scheduling and time clocks and building automation integration all the way down to the sensors in the room, all the way down to something that we call digital lumen management, which is all the way down to the fixture level. It's where we then build up the total energy savings across all those dimensions of controls to actually you can achieve energy savings that are as much as 2/3. And that's, I think, the green bar showing the energy savings as you're combining these strategies. And then finally, as you move to solid-state sources, the more you dim them, the more you turn them off, in a linear way, you extend the life of that light source. So smart controls save you money, extend the life, give you a lot of flexibility in design. And we're just going to kind of focus in on one of the control strategies. One of the things that I've been told by a lot of people, a lot of facilities folks who have done major lighting renovation projects, is that of all the things they did over the years, the sensor project was the one that was the simplest, the fastest, had the greatest impact, and the greatest return on investment. So I encourage people to start with that one. And that's just sort of a strategy that here's the quote, actually the quote, where somebody, this was Cincinnati Public Schools was the latest person who told me that, but I've heard it from a number of people. And one of the strategies I really encourage people to adopt as they work on school lighting renovation efforts. But first you have to have a bold plan, right? So how do you have a big plan that allows you to then focus and act quickly? And so it really is about finding an application space or a technology, testing it, piloting it, validating that it works, and then scaling that across your campus to gain the maximum benefit, and then come back and solve the next application. So let's talk a little bit more about sensors. So before we talk about them, we'll have a test. I'm curious as to your experiences with sensors in your projects. And this could be with your school, this could be in your life. I have sensors on some of my light fixtures at home, and I have to admit, I did a really bad job on it, and I'm not happy with them, and so I'm going to get to redo it, and I get to re-spend the money. So that's just one of my learning experiences. But just take a minute and just sort of pick the one that is best characterizes your current thinking about lighting sensors, occupancy sensors in particular. I'll be curious to see what your answers are. I know what they typically are, but it'll be great to see. All right. So the design challenge for the building is the lights are on, but the space is when a space is unoccupied. Traditional sensors can't see through obstacles or walls, and then the traditional sensors can only have very simplistic responses. What we're looking for is to be able to design a solution that uses multiple technologies, that uses passive infrared, that may use ultrasonic, it may use microphonics, it may use a combination of those technologies to best understand what's happening in the space so that it can respond accordingly. We're also looking for sensors that enable something more than a very simplistic answer of off-on. We're looking for sensors that can do things like have multiple stage outputs. So when the sensor determines vacancy, the sensor can turn the lights off. The sensor can then wait to make sure that people they're really gone. They haven't been back for 10 more minutes. So now I'm going to start setting back the HVAC or close some air handlers. So how can I program the events that are triggered by this sensor to create an even better experience in the space? We need lots of options. One of the things you see as you look at a school, particularly a bigger school, is it is almost a small city. There are classrooms and hallways and stairwells and offices and bathrooms and gymnasiums and locker rooms and kitchens and cafeterias and storage closets, and all of those things may require different kinds of sensor implementations. So it's not like you can just go buy a truckload of one sensor and then start putting them everywhere and have it turn out to be a good experience. You can turn all the lights off, but you might not have the kind of experience that you're hoping to have. Let's just talk for a bit about the three main methods of sensing when something is in the space. The first is passive infrared. That's the oldest of the sensor technology. And essentially what happens in that is the way to think about it is every facet of the sensor face is sending out a beam that covers its angle of the space. And it's almost like one of those remote point and shoot thermometers. You point it up at something you can't reach, it'll give you the temperature. So it knows the temperature of the things within its line of sight. And so it's happy. It doesn't care what the temperature is as long as it doesn't change. So as long as the temperature doesn't change, then it's assuming nothing is moving in the space. It also knows if a temperature moves from one segment to another, and that's also a clue that something is moving in the space. Ultrasonic deals with sound airwaves and sound waves to sense when something is in the room. And then microphonics is essentially listening. It is audio. It hears something in the room. So let's just kind of drill down into a little bit more about that. So as we think about, here we go. They don't work in most places. You guys don't like sensors. That breaks my heart. I'm crushed. But it's an opportunity, right? I think we can see there's a need for them. And if we could get them to work, it seems like something we would want to do in our spaces. Oh, I'm sorry, I misread that because it was red. They work well in most spaces. All right. So that's excellent. Good news. Thank you. All right, two kinds of sensor solutions: wall-mounted and and ceiling-mounted. The wall-mounted is simplest. The ceiling-mounted gives you a bit more flexibility. Let's drill down on each one of those. So wall switches are simple to add. They can be added in any space that is up to about 20 by 20. So typical small office. You typically wouldn't put them in a bathroom, but a small office, any kind of small space, closets, probably not as big as a classroom. Just wouldn't be big enough. A copy room, that sort of thing. They can come in multiple configurations. You can have single technology sensors and dual technology sensors for wall sensors. So in some places, a copy room, people will definitely be moving around, whereas in an office space, people may be sitting, and you would need the microphonics in addition to the passive infrared. So it's important to choose the right kind of wall switch for the right kind of space. The way we typically recommend that people do that is to provide a floor plan of the space to us through Graybar, and we give that to our control specialists, and they actually go through the whole space and mark it up as to what's the appropriate sensor technology for that space, and they'll based on standards of room size, room dimension, and if whether or not it needs more than one sensor. This one is very simple to install. You simply take the old switch out of the wall, wire up the hot, ground, and neutral, and put it back in. It has sensitivity controls baked into it. It's very controllable by the user. As a practical matter, it would be any commissioning would be done by the person installing it, and a typical room occupant would not have the awareness or patience to do any resensitivity settings on it. It was something you'd have to do through engaging facilities management. So all the more reason to test it and put it into certain places. To test it in certain kinds of places before you go whole hog. Ceiling sensors typically are passive infrared. They have a much broader spectrum of coverage. They can go in odd-shaped rooms, and so those also come in multiple technologies, single, double technologies. Okay. In addition to these kinds of sensors, the other sensor that is very important to put in the space is photocells. So photocells can be very effective in switching lights off, which is a good thing. They're even more effective if you have LED sources in the space, and it allows you to dim the LED light fixture to compensate for the contribution of daylight. So if I have a certain amount of daylight, of lighting contributed by daylight, the photocell tells the fixture to dim the appropriate amount so that the occupant has an appropriate amount of lighting. A couple things that are useful about this. One of the concerns about photocells is they recognize light changing. They have algorithms in them. So when a cloud passes over, they don't instantly turn the lights, up full bright. There's an algorithm in that recognizes, well, the lights have been dimmed for a few seconds. I'll give it a few more seconds, and then I'll start easing up the ramp speed. And it does that change of light intensity up and down in a thoughtful way, if sensors can think. But there's programming into that so that it's not distracting to the user. I've been in a lot of conference rooms and a lot of classrooms where if you're not paying attention to the lighting, you don't really realize that things are changing. I was in a Walmart not too long ago, and I think it must have been an older Walmart. It had a lot of skylights and light and photocells, and lights were turning off and on. It was sort of like a really, really, really bad concert. Just lights were going on. It was very distracting. And so one of the things you want to do is make sure that you have a photocell that is able to adapt and provide a very comfortable experience in the place. Things like the microphonics, let me just back up to that for a second. They also have algorithms in them. They recognize ambient noise in the space. So if that sensor continually hears, let's say, a radio playing in the room, it comes to understand that radio is there all the time, and it ignores that part of the spectrum while it's making decisions about whether or not it's hearing people activity in the space. The next kind of control that I think is really interesting and useful, and it's a new thing, all right, because up until very recently, outdoor lighting, for the most part, was high-pressure sodium, HID, low-pressure sodium, metal halide, whatever it was not easy to turn off and on. You sort of turned it on when it got dark, and then maybe a scheduling system turned it off after some normal business hours or normal campus hours, and then it maybe came back on schedule a few hours or shortly before the workday began, and then went off when it became daylight. You just didn't have the option of including dimming and turning lights on and off based on proximity or activity in the space. So now with more modern sources, with LED sources, we're starting to see photocell outdoor sensors that have proximity sensors. For some reason we call it proximity sensors outdoors. And they can either be mounted to the fixture, so we see on the left-hand side it's sort of this I don't know what you call that. It's a little bolt-on. It's not very attractive, but it works. A newer fixture you see where you don't even see the sensor. It's embedded in it. It's part of the fixture design. The pole-mounted sensor, in this case, is mounted at a lower level. We see in parking garages where we will have sensors independent from the fixtures, and they will recognize that there is activity on the floor, and they will turn the light on in whole zones. Because we want to think of a parking garage, we want that event of activity in the space to say, it's time to light up this whole floor. I don't want to just light up the person walking through the space. My boss says that's the equivalent of lighting up the victim and not the perpetrator. So that sensor needs to understand that I'm lighting up this whole space so that the occupant can feel comfortable and see and know that they're in good shape for the whole floor. So that's basically the portfolio of sensors. They come in a wide variety of what we've seen. I think, for example, a very exciting new technology we have is called X-Point. These sensors are both wireless and powerless. The wall switch itself requires no lines to it. It requires no power to it. The act of flipping the switch, or pushing the button actually, creates enough kinetic energy to generate the wireless signal to the other equipment in the room to take action. The occupancy sensors and the photocells are also wireless, and they require no power. They get their power from the ambient light during the day. So it's a really exciting time, some really cool new things happening with sensors. One of the things we talk a lot about is that we need to program the space, and I'm going to, for the sake of time and respecting everybody's time, I'm going to skip through these, and I just want to point out that for every space type, we want to think of the user experience. We want to think of what happens through the course of the day, through the changing activities, and how can we create a control environment that makes sense for that space. And the one I always encourage people to think about, because it is a mind-opening experience, is think about the gymnasium. When you convert your gymnasium from high-pressure sodium to even fluorescent or potentially LED, you really get to ask the question of how should this light be owned during the day? What zones do I need? What light levels do I need for all the different activities that happen through the course of the day? And sitting down with your control specialist and thinking through that and talking about that and jotting down what those activities and that sequence of operation would be really opens up your eyes to some of the things that sensors can do. I want to close with this one last example of a sensor project. And this is a sensor project we did. It was in partnership with Graybar. This was done at the University of Minnesota. And one of the things we know from our data earlier is that stairwells and corridors are mostly empty, mostly unoccupied, but the lights are always on. And that's a challenge. So in this case, we're looking at a product called Lithonia Lighting WL. It has an integrated in-light sensor that you can see there in the left-hand corner. And not only does it, this is an LED option, so not only is that fixture in the space, and when the space is unoccupied, that luminaire operates at, let's say we configure it to run at 10%. And we know that stairwells are occupied unoccupied 95% of the time. So for 95% of the time, I'm using 10% of the energy of what that luminaire would normally do. The beautiful thing about this is when that third floor landing becomes occupied, that luminaire immediately, because LED is an instant source, it goes from off to full bright instantly. Even a fluorescent takes up to 90 seconds to become full bright. So it becomes full bright instantly, so the person who's on the landing now has great field of view. Even at the 10%, it meets the fire code egress requirements. And even better, because we've now been able to program this sequence, the fixture on the third floor sends a signal out to his neighbors on the fourth floor and second floor, and those fixtures become full bright at the same time. So as I'm traveling up or down the stairwell, the lights are coming on ahead of me, and I'm never uncomfortably walking into a darker space. So the bottom line on that is you can save up to 90% of the energy 97% of the time. We did a huge project at the University of Minnesota. They implemented this. It was in partnership with Graybar and our agency there in Minneapolis. And this case study is available. You guys can download it. There are links at the end. But they ended up, and it was the return on investment was less than 2 years, and they're saving, after that, they'll be saving $30,000 a year on just the West Campus portion. So great project, a really good example of smart sensors integrated with another layer of modern lighting technology to create a space that works better, costs less, and the maintenance is just not an issue because of the long life of LED. And with that, I just want to kind of wrap up with a set of resources, share these with you. There are links in this presentation, so as you go through, you can download those. AcuityBrands.com/schools is my website. The Graybar.com/PowerSmart, that's Carl's website. Sensor Switch Data Logger is at sensorswitch.com/datalogger.aspx if you want to jot that down, or just click the link on the PDF. Free assessments are available from the Graybar team. Acuity has a great trial installation program. You can do a trial installation in a certain space. If you don't like it, you don't have to keep it, and you don't have to pay for it. So I always encourage people to test these things, do your homework, test these things, prove they work, and then that gives everybody the confidence to proceed quickly. We do workshops and training. I've done 5 events this year with Graybar alone in 5 of their major markets. Karen Gale, who does healthcare, and I did a half a day of training for their folks and some of their customers, and it's a great event. We'd be glad to customize some training for you or for your team to focus on an area that you think is a challenge or a problem. We want to know what the problems are. As you look around your campus, I describe it as crimes against lighting. What crimes against lighting do you have on your campus? And those are things like lights are on when the space is unoccupied, T12 lamps, HID lamps. Parking garages are the poster child for energy wasting. There's just lots and lots of opportunities to save some money, to save some maintenance, and create a space that looks better and works better. Have case studies for indoor and outdoor lighting, gymnasiums, and whole schools and classrooms, etc. Carl and his team will provide some of those in a follow-up email, and I'm always eager to put those, to share the information we have so that people can make good choices about lighting. And with that, I think I'll kind of wrap it up. We'll turn it over to questions. I hope this was helpful. And Carl, have we gotten any questions along the course of the presentation?
We do, Tim. Thank you very much for your presentation today. It was outstanding. As we go down, I have couple questions I'd like to ask as we give people an opportunity to type their question. Just go down to the bottom of the screen to the Q&A button, click it, and then type your question in the dialog box, and we'll get to it. But as we're waiting for the questions to come on in, I have a couple. There's a terminology we're hearing in sensors. One of them's occupancy sensors, and the other one's a vacancy sensor. And to me, they kind of seem like the same thing. But what's the difference between occupancy sensing and vacancy sensing?
That's an excellent question, and they do sound like the same thing, but they mean very different things. So occupancy sensing says, I recognize an occupant came into the space or is in the space, so I turn the lights on. The system recognizes human motion or human presence and turn the lights on. And the lights stay on until it no longer senses occupancy. Okay, so that means it's something we learned a few years ago, that when I walk into a room, the lights should come on, right? And so now it just irritates me that I have to go to all this effort to turn the lights on. That's sort of old thinking. New thinking is, maybe I walked into a room and there's daylighting and there's plenty of lighting. Why would I need to turn the lights on? It requires the person coming into the space to make a conscious decision to spend energy to turn the lights on, okay? And those lights will stay on until the room becomes vacant, and then it will turn the lights off again. And that's an issue, that's a requirement that is now becoming part of a lot of codes. Title 24 in California has that for certain space types, for buildings over certain sizes. ASHRAE 2012 talks about vacancy sensing. And I think that will become the new normal, is you will come into the space, you will turn the lights on at a level that's appropriate for what you plan to do in the space. So in the old days, I may have come into a classroom and the lights come on full bright. maybe I need to come into the classroom and I just turn it on to 50% mode. Or if I'm the maintenance staff, I don't need full bright in the gymnasium. I only need enough for navigation. So it allows the person coming into the space to make a decision about the amount of light they need and the amount of energy they want to spend. And that's the difference between vacancy sensing and occupancy sensing.
Great. A couple people have asked in the Q&A about the reference materials that were mentioned in the presentations. I wanted to let everybody know that if they go to graybar.com and click on the G2 Talk webinar logo and go to the archive, that those documents that were referenced here will be posted there along with the links, and you can get it. You can also get a copy of the presentation there. I'm assuming that Tim will allow us to have that in a PDF format. If not, you can see the video there and see the presentation. So those resources that Tim mentioned in his presentation will be up online. There was another question that came in here that had to do with dimming. And it says, in dimming with photocells, wouldn't we want the photocell per fixture in order to adjust the light levels in different parts of the room? Or do you segment the area? Do you segment it by area? I kind of know the answer to this, but would you tell us a little bit about the necessity of putting a sensor on every fixture, whether we need to do that or not? Can you address that, Tim?
It generally is not necessary or desirable to put a sensor on every fixture. Think about a real typical application, so a classroom that has windows on one wall. And in that classroom, we have 9 fixtures in the ceiling, so 3 rows of 3. The row next to the windows is the one that's going to be most affected by daylighting. The row away from the window is going to get daylighting has a very difficult time penetrating the space horizontally. And lighting doesn't like to travel down and then sideways. So you want to think about what the daylighting zones are in that classroom. So in that first example, the row of fixtures next to the windows is the daylit zone. So your photocell would only apply to those 3 fixtures. Does that make sense? Now, the great thing about the way in a very distributed world now where every fixture is a node on the network, in addition to I have another zone in that classroom, and that zone would be the whiteboard zone or the front of the room zone. So I may want to dim the front row to do an audio-visual presentation. So you have to determine which of the sequence of operations will control that fixture that is at the intersection of the daylit row and the whiteboard row. And so for me, it would be the whiteboard row. So if I dim the lights all the way across, then that's the row that's the zone that overrides the daylit zone. So it's a challenge, and I've done a couple projects where I think there were like 8. A recent one I did, there were 8 different classroom configurations. Some had clear story lighting, some had windows on one wall, some had windows on 2 walls. And for each one of those, and there were other combinations, some had window wells. It was a challenging project because every classroom was a little, there were 8 configurations. And so we essentially had to create a set of zones that was appropriate for each of those and then program the lighting in the appropriate zones.
Great. Paul asked a question, and it has to do about not a complete upgrade, but partial upgrade. And his question it goes like this: can you please discuss how sensors need to be correctly paired to LED lamps and fixtures, and what tools you have to do this? And he gives an example where you replace can fixtures with LEDs, and the current dimmers may not be compatible. Can you discuss a little bit about dimming compatibility and upgrading a space, maybe partially LED but not 100% LED?
Yeah, that's a good question. So if we were thinking of this sort of broader lighting renovation where we're replacing some of the lighting but not all of the lighting, dimmers that work with fluorescent I would never recommend people reuse dimmers that were working with fluorescent for an LED upgrade. It's just, I can't. It's like a floppy drive on my iPad. I mean, who wants that? Maybe I'd like a flash drive on my iPad, but not a floppy drive. I think so. Once you choose that LED source, it needs an appropriate control mechanism, something that has the kind of fidelity and is engineered to support that output device, that node on the network. So when you have an old lighting system and a new lighting system, so let's just say I'm replacing my downlighting in the space with LED, but I'm keeping my general ambient fluorescent, I think you're going to end up with two control mechanisms in the space. So you're going to have a circuit or a switch for the downlighting in the space, and a circuit and a switch for the ambient, and you might have different levels of control capability for those two different lighting networks. So your ambient you might have had bi-level switching, and that's awesome, right? And so you would continue to have that, but then you might have 0 to or 100% to 0.1% dimming on the downlights. So it's a transitional thing. I never recommend using fluorescent capable dimming on LED fixtures.
In the presentation, Tim, you mentioned X-Point, and in my vernacular of sensors, I call that kind of lick and stick wireless sensors. Is X-Point available now?
It is available now. It's a product that we're shipping now, promoting it now. It really is optimized for a place where wireless is ideal. We have 5 different communication protocols for our various sensor offers. So we have Cat5 cable we have Cat5 cable, we have line voltage. So we have low voltage and line voltage. We have 3 or 5 different wireless protocols. So one is a mesh network, one is runs on the Wi-Fi network, one uses Zigbee. So it is about choosing the right technology for your space. And this is the point where I claim ignorance. I just claim ignorance, and I'd say if we really wanted to go deep on the different wireless protocols and which was the right one for which space, I would say I know a controls guy who we could hook you up with. But X-Point is out. So those 5 different protocols are they're commercially available and ready to go.
I need to remind everybody that we're going to run out of time here quickly. So I'm going to read one more question to Tim that came in. If you have a question that you posted online, we will respond to it via email after we sign off. So here's our last question right now, and that has to do with setting up daylight harvesting in the classroom, and then the teacher makes a decision that they want to control the lighting even further, add more dimming into the room. How does that work with daylight harvesting and then more dimming? I think we're going into a little bit of advanced control here, but could you describe that just a little bit, Tim?
Yeah, I mean, I think so. I would think that the daylight harvesting is independent of what the teacher does. So if the teacher has, let's just say we give them the teacher has a wall slider, and the slider lets them run the lighting from 0% to 100% in a one step at a time. That's cool. So what would happen is every fixture that is not on the daylight harvesting in the daylight zone would be going up and down at the teacher's command. The daylight zone would be doing an algorithm that says, because I'm feeling 40 foot candles of light, or I'm sensing 40 foot candles of light coming into the space, I need to tell these guys to turn themselves down even further than the other zones. Does that make sense? So
it does to me.
What would happen is the daylit zone would potentially be brighter than the dimmed zone, unless, and this does get into advanced controls, unless you've integrated your daylight harvesting and your control system with your window shades. And we've done that on a lot of projects as well, so that when I put the classroom into audio-visual mode, it closes the window shades. That makes sense, right? So even during the middle of the day, I can get a good experience of being able to see the video. So it is more advanced. It is not I won't say it's not a difficult problem, but it's a problem that's been solved many, many times, and we would just need to get the right folks to sit down with, was it Paul or whoever asked that question, and it is absolutely addressable. Carl, if I could, before you sign off, I'll sign off for my part and say thank you for inviting me to do this, and thank everyone for joining in. My email address is tim@acuitybrands.com. That's it. If you just send it to there, it'll come to me, or work through Carl. I'd be glad to talk with you, send you information. I work with Graybar. I love these guys, and I really admire what they're doing with the PowerSmart program, because it is about you guys, the facilities folks, having a trusted advisor to help them make good decisions to maximize their investment in making their campuses work better and smarter and using less energy. So thank you all for letting me be part of this discussion.
Thank you, Tim. And if anybody would like a Graybar person to come by and have a discussion about controls, or maybe do a walkthrough and an assessment, just type the word assessment in the dialog box at the Q&A, and we'll pick that up and make sure we get somebody in touch with you. Again, everything's archived at graybar.com. You can go up there and get more detail there. Go to the G2 Talk webinar link and follow the archive link there. If you're online and you were one of the first 50 people, check your email. You may get a cup of coffee. Thank you very much for joining us today for our G2 Talk webinar on lighting controls in the education space, and we look forward to seeing you the next time. Have a great day.